Welcome to this video lesson. In this video, we will be looking at how to draw interaction and force diagrams. The goal of this video lesson is to figure out how to sketch force diagrams. There are so many different types of forces, and there are some common ones that we're going to look at right now. The first very common type of force is the gravitational force. And this is an invisible attractive force between objects as a result of their masses. So if you have two objects, they will have a force between them. And it is always an attractive force. They're always pulled towards each other. And this force is always strongest when the objects are close to each other, and it gets weaker and weaker when the objects get further and further away from each other. So when you get further and further, this force just gets smaller and smaller, and when the distance becomes approximately infinity, this force also approaches to a value of 0. Now, with regards to gravitational force, when we have two objects like two people here, the force between them is so small that we often call it a negligible force, something that's very tiny. So in order for us to really take into account this force, we have to look at objects that are very massive. So in this case, for example, when we have an object close to Earth, Earth is pretty massive, and there's going to be a force on the Earth, and there's going to be a force on the object here. But this force is reasonably large enough that we need to take it into consideration. But if you had two objects close to each other, let's say we had another object here, draw that with red, there's going to be a force between these two as well. These forces are going to be towards each other, but they're going to be so small that we don't really care about them. But the force is acting from Earth to this object and from Earth to this object, that we do care about. That magnitude of that force is much larger. This force is also called the weight of an object, so that's another word for it, and we'll talk about that when we get to the second law of motion. The other force that's also important, two other forces that are invisible, things that we don't see, are one is called electrostatic and one is called electromagnetic. And electrostatic is caused when electrons are removed or added to an object, and this object becomes positively charged. And let's say we have electrons being added to this object, and this object becomes negatively charged. And two opposite charges will have an attractive force between them. And it works very similar to gravitational force. So the closer they are, the stronger the force, and the further away they are from each other, the force is reduced. And if we have two like charges, they will repel. And if we have two opposite charges, they will attract. And we have magnetic forces as well. With magnetic forces, if you have the same poles, then they will repel. And if you have opposite poles, they will attract. These two types of forces, gravitational and electrostatic and magnetic forces, are things that we can't see. And these are 2 out of 4 fundamental forces in the universe. And we will talk much more about them in the quantum physics section. But at the moment, that's all you need to know. They're invisible. We can't see them, but they do exist. The one that we are going to use a lot is gravitational force, and we will only take them into consideration when they're acting on very massive objects. So when we have an object like Earth. Let's talk about the other forces here. We have a few contact type forces. We got normal, friction, tension, and air resistance. So let's talk about some of them. Let's think about a textbook on a table. So I'm going to draw the textbook using, there we go, that's our textbook. And this textbook over here, if this table wasn't here, this textbook would have fallen. So there's a force that's pushing the textbook upwards, that is what we call a normal force. And a normal force always acts normal or 90 degrees to the surfaces. In this case, we get the two surfaces in contact, and this force is 90 degree to those surfaces. Now, if you were to push this textbook in this direction, then there will be another force that tries to resist the movement of the book. That force is called a force of friction, and that always acts parallel to the surface and is a force that resists the relative motion between two surfaces. So if this is trying to go in that direction, this is going to pull it back. If it was going to go in this direction, the surface is going to try to pull it back in this direction. There's also a force of tension. So if we were to attach a rope and try to pull this object, the rope is in contact with the object and it will pull the object in this direction. We call that force the tension force, so Ft. Sometimes we use letter T for this. Sometimes we call this reaction force as well, so we use different letters for these. Finally, the other one is air resistance. So if an object is moving in this direction, there will be air particles or fluid particles that will collide with an object trying to slow it down, and that's what we call air resistance or force of air resistance. So these are our forces. Let's talk about interaction and force diagrams. So when two objects affect one another in some way, we say that they interact. Today we begin exploring the nature of these interactions and free body diagrams. This lesson is adapted from Mr. Chris Meyer, and this is the lesson from 2014. So you can try this activity on your own, so you can actually, especially this first part of it, just pause the video, think about it a little bit, try answering the questions, and then I'll go over it. Okay, we got a friend of yours kicks a soccer ball, which you record on a video. You carefully watch the video frame by frame and think about the interactions that are present. So there is interaction between the foot and the ball. In which frame is this interaction present? So foot and the ball, in the first one, they're not really interacting, they're far away. There is actually a gravitational force between these, but it's so small that it's negligible. In this frame, they're in contact. So there's an interaction or a contact between them in frame 2. And also in frame 3, they're also still in contact, but they're no longer in contact in frame 4. So we don't have to put that in. And then what evidence is there that there are interactions between the foot and the ball? And why do we believe that the ball is affected in some way? Is the foot affected in the same way? Your friend should definitely notice this. Well, we can see that in these situations, there is contact. And contact is what's causing the interaction. During this contact, this person will feel the soccer ball, and the soccer ball, if it had feeling, it would feel the foot. And they would both in this situation and in this situation. So contact is the main way, and both of these objects will feel some sort of contact. Note that the ball and the foot interaction is an example of contact interaction. Such an interaction is only noticeable when the two objects are in contact. When they're not in contact, there is no interaction. Now, does the ball participate in any other contact interaction? In which frame and between which objects? So the ball, in the very first one, it's in contact with the ground. In the second frame, it is in contact with the ground. In the third one, it's not, and the fourth one is not. So in frames 1 and 2, contact with surface, or I'm going to call it ground. Non-contact interactions can take place when the objects are not in contact. Even though the objects are separated by some distance, they still have an effect on one another. Note that the interaction always involves a pair of objects. Does the mass of Earth participate in a non-contact interaction with the ball? As we talked about this just previously, um, Earth is massive and will pull the soccer ball towards it. And basically, you know this because as soon as the soccer ball goes up, it will start slowing down, meaning that something is pulling it down, and then it will come down, and that is the gravitational force pulling the soccer ball downwards. And there is an interaction between Earth and the ball, and it comes from that gravitational force. Now, I'm just going to zoom in a little bit. I think we have a very small picture here. For the purpose of understanding interaction, we think of and describe the ground and Earth as two separate objects, since they often participate in interaction in different ways. We can construct an interaction diagram, or ID, to help represent the interactions present at some moments in time. An ID lists all objects that are interacting with one another and has lines representing each interaction. The lines are labeled with a single letter describing the type of interaction. So it could be friction, which should say parallel. Parallel to the surface in contact. There's gravitational, or G, R, and N for normal reaction, and many more. There can be many interactions in a given situation, so we need to narrow our focus by selecting a system, which is an object or collection of objects whose interactions we're interested in. We show the system object by drawing a circle around them. We will usually leave out other interactions that don't involve the system objects. So in the chart below, complete the interaction diagrams for each of the 4 frames of the video. So we're going to look at the ball in each situation. And in the very first situation, it is in contact with the ground and it's being affected by Earth. It's being pulled down. Gravitational and normal force from the ground. So I'm going to zoom out so we can see all of them, and we're going to draw them out here. So you can try drawing them out on your own first and then check the solution. So on frame 2, we have the ball, and it's interacting with the ground, and that's normal force because the ground is pushing it perpendicularly upwards. It's also in contact with the foot here. Now, within the foot, there's a contact, and as soon as, actually, even with the ground, sorry, there's a normal force, but also, since it's starting to want to move in this direction, the ground is going to start pulling it back. So there's also a frictional force here. It's also in contact with Earth. Not in contact, sorry. It has a gravitational interaction with Earth. The Earth is trying to pull it down. And there's also the foot. And the foot is kicking it. So there's a contact force, and whenever there's a contact force, which comes from a touch, and it's not a string or a spring or a tension force, then there's always a normal and frictional force. So the normal force is going perpendicular to the two surfaces, and frictional force is going parallel. Sometimes we combine these and call them applied force. And another way, says we don't usually call the one from ground applied force, but the ones from foot is kind of applied to the ball. So sometimes we combine these and say that they're the applied force. But note that whenever we have applied force, we often have a normal and a frictional force. Let's do the third one. And that's it. There's no other interactions with the ball in that one. In frame 3, so this was frame 2. In frame 3, we have the ball. And in this case, we got it's in contact with the foot. And it's also interacting with the earth. With the earth, it's gravitational. And with the foot, it's a combination of friction and normal. And sometimes we say this is applied. It's not interacting with anything else, the ball in this case, because it's not really touching the ground, so there's no touch, no interaction. Finally, for the last one, stage 4, we have the ball. And the ball is not interacting with the ground, it's not touching it, it's not touching the foot either, but it is interacting with the earth. And that's an invisible force that's pulling it down, and that's our gravitational force. This is how we draw our interaction diagrams, and these are so important because basically we can use this idea to figure out what forces are acting on our object. So in the second frame, we have 1, 2, 3, 4, 5 different forces acting on the ball. On the third frame, we have 1, 2, and 3, and we can combine these two into 1, so we can say it's 2, and here we could say 1, 2, 3, 4. And on the fourth frame, there's only one force acting on our object, and that's our gravitational force. And our next step will be to kind of combine all of these and draw the directions in which these forces act on our system. Let's go do that. Before starting, every interaction has two parts called forces. Intuitively, a force is a push or a pull of one object on another. In our previous example, we say that in frame 1, the ball is interacting with Earth through gravitational force, and the ball is interacting with the ground through the normal force. There could also be frictional force, but in this case, because nothing is trying to push it, there is no resistance, so friction is just 0. Description of force should include its magnitude, direction, the object on which it acts, and the object that exerts the force, and the nature of the force. So for example, 30 Newton pulls at 10 degrees to the horizontal, acting on a crate from a person. So look, we got the magnitude, we got the unit, and we get the direction, 10 degrees to the horizontal, the object that it acts on, the crate, and the object that exerts the force, that's the person. In physics, we simplify the real world in order to focus on the basic ideas. Instead of drawing a beautiful diagram of the object each time, we will represent it using a model. We will model all our objects as a point particle. And in a point particle, what we mean is that we imagine all of the mass of the object is compressed into a single point. The diagram we create is called a force diagram or a free body diagram. A system is the object or collection of objects we're interested in studying. At our level of physics, we will think of a system as a single object with the combined mass of all objects inside of it. The environment is composed of the other objects outside of the system, which interact with our system. A force diagram, or a free body diagram, only shows external forces. I've highlighted this, I'm going to highlight it, I bolded it, I'm going to highlight it again. Force diagram only shows external forces. These are the forces from interactions between the system objects and the environment. They do not show internal forces, which are forces from interaction between the system objects. So for example, if we had a ship and in our ship we had pirates fighting, and this was our system, and the waves were kind of pushing our system here, we only care about how the pushes are happening from the waves into our system. We don't really care about anything that's happening inside here. Let's do a few examples on force system or force diagrams. And we're going to do interactions, and we are going to do some force diagram. For interactions, let's do interaction of A here, we'll do A here, and we'll do A. Okay, let's look at the first one. So interactions on A. A is this one over here. And we can see it's interacting with the ground. So we got A, ground. Within the ground, it could, because it's a surface, two surfaces touching, parallel, because it could be pushed from B in this direction. So there's some frictional force. And there's a normal force because the ground is pushing it upwards. There's another touch over here, so it is in contact with B, and they're touching again, and as soon as they touch, there could be a frictional force and there could be a normal force, and it's interacting with the Earth, and that's through gravitational. And that's it. A is not interacting with anything else. So there's the Earth, there's the ground, and there's the surface. There's something pushing B, but that's not that's not directly in contact with A, and we don't really care about it if it's not directly contacting A. Now, how do we draw a force diagram? Oh, this is fun. What we're going to do is we're going to, instead of drawing the whole box, we're going to draw dots, and we're going to kind of compress all of this mass into this little dot over here. And we're going to start looking at the interaction. So the ground is going to push it upwards, and therefore I'm going to draw a force going upwards, and that's from the ground. That's the normal one. So this is the normal force, and it's coming from the ground and going to A. So this is showing the direction. This is the magnitude. This is the type of force, ground to A. And there could also, from the same one here, from ground, if this object is kind of like pushing it down, this is going to move the box, try to move the box in this direction. And if the box is going in this direction, the ground is going to try to pull it back. So there's going to be force of friction. So that's this force over here. And that's going to be ground, from ground to A. Okay, and then there's there's gravitational force. So gravitational force will be pulling our object towards Earth. Earth is, we're assuming that Earth is here. So there's going to be a force acting in this direction, and I'm going to call that force of gravity. For force of gravity, usually you don't have to say where it's coming from. I'm just going to say it's from Earth to A though. We've taken care of this. There's two more forces, friction and normal force here. So frictional force, you can see that here there's a touch. And because of this touch, this object is, there's going to be a normal force. So B is going to be pushing it in this direction. That's the normal force from B to A. And if this is going to come down, this is going to be pushed this way, and there's going to be a little bit of a frictional force down here. So if this is moving in this direction, then B is going to try to pull it in this direction. So there's going to be a force of friction from B to A. Now we've taken care of all of our forces. We get 1, 2, 3, 4, 5, and we get 1, 2, 3, 4, 5. So basically here we're saying which direction do these forces act in. And at the moment, don't worry about the magnitudes. We're going to start talking about magnitudes later when we have better idea about what their magnitudes are. Some forces will be bigger and some of them will be smaller. Now, let's do a force diagram on AB as well. So AB would mean that we are taking this whole thing to be our system. So this is our system now. So now we don't care about any of the internal forces, so we don't care about this contact anymore. We only care about anything that's touching the boundaries here. So there's a touch here. I'm going to start labeling these forces so that we have a little bit, or these surfaces. So I'm going to call this a force, let's call this force C. And let's call this surface M and this surface N. Just makes things a little bit easier. So for our object here, there is this force pushing it downwards. So I'm going to draw that. And that's going to be the force from C to AB. There's also force of gravity pulling it downwards. There's interaction from Earth, so I'm going to draw that. There's force of gravity. Force of gravity, again, I'm not going to draw it twice. Oh, sorry, I'm not going to label that as from Earth to AB. It's understandable. And there's going to be a push from this surface in this direction. And there's possibility of force of friction as well, because if this is coming downwards, or if this part of it is trying to come down, this is going to be pushing it upwards. So there's going to be a force of friction in this direction from M to AB, and there's going to be a push in this direction, force of N from M to AB. Okay, good. We're almost done. There's also an interaction here. Normal force going in this direction from surface N on our system. And if this is going to be going this way, this surface might be pulling it back in this direction. So there's going to be a force in this direction, which is going to be force of friction from N to AB. And what other forces do we have? We get the normal force going upwards, so draw that like here. And that's force of and normal force from N to AB. So a lot of forces acting on this, but let's just review. Force of gravitational force, that's 1. Surface, 2 possible forces. Surface, 2 possible forces. So 2, 4, 5, 6. And we got 1, 2, 3, 4, 5, 6 forces acting on it. Okay, let's try the next one. For interactions, we got A interacting Earth, gravitational. It's interacting with the ground. That's contact, so that could be friction and it could be normal. And it's, okay, what else is touching? So it's touching the ground, already taken care of. It's touching this rope over here. And this rope kind of goes back and goes to B, so I'm actually going to say it is an interaction with B. And with B, it's got the rope, so that's tension. There's also interaction with B and the surface, and that could be a force of friction and normal force. Oh my God, a lot of forces in this. Let's draw it out in terms of direction. So Earth that moves downwards like this. So I'm going to call that force of gravity. Okay, in terms of the fourth type of forces now, we have the tension force. It's going on an angle in this direction, so I'm just going to draw it like this. I'll put the arrow here. I'll make it a little bit smaller actually. I think there's going to be a lot of forces here, so I'm going to add them all up. I'm going to show you a different way of doing this. This is force of tension from B to A. And there's this surface over here. So within that surface, there's going to be, if this is moving in this direction, this is moving in this direction, then block B is going to try to pull A in this direction. So that force is going to be in this direction, and we are going to call that force of friction from B to A. What else do we have? We got the normal force because we got A here and B is going to be pushing it in this direction. So normal to it. So that's going to be in this direction. And that's going to be, I should start labeling these with different colors because it's hard to see now, but that's okay. We get F and B to A, pushing A in this direction. And we've now taken care of Fg, we've taken care of the force of friction from B to A, force of normal from B to A, force of tension from B to A. Okay, now we have to take care of the forces by the ground. So the object is moving in this direction, so the ground is going to pull it in that direction. So there's going to be force of friction from ground to A. And there's going to be a normal force from the ground pushing A in that direction. So I'm going to draw this force over here. Note that normal forces are always perpendicular to the two surfaces, and this is going to be the force normal from ground to A. Fantastic. Now we've taken care of these two forces as well. Okay, forces on B. There's a little bit less interactions for B. So I'm going to draw the dot here. We can see that there's a contact force here, gravitational, and a tension force. So the contact, so interactions with A, there's a lot of them. If this is going in this direction, A is going in this direction, there's going to be a force of friction parallel to the surfaces acting to the right. So I'm going to draw that here. That is force of friction from A to B. And then, is there anything else in that? And then there's the tension force. So if this is going in this direction, the tension force is going to try to pull it back. Tension force only pull. And in this case, the tension force is pulling in this direction. And that is also caused from object A, because it's attached to A right here. So this is going to pull it back, so that's this force over here. There's going to be a normal force as well from object A, so that's going to be the normal force from A to B. So this surface had two, the normal and friction, so we've taken care of that. The tension force here was taken care of. And the only other thing that this is not touching anything else. The only other interaction is with Earth. Don't forget that one. That always acts towards the Earth. So Earth, in this case, we're assuming that is down here, and that's why we draw it directly downwards. All right, let's do one more. We'll do this one. And in this one, we got interactions of A. Let's look at it. It's interacting with the Earth, and that's through gravitation, and it's interacting with the little rope here to the nut. So I'm gonna say, the nut through tension. And what else is it interacting with? The surface, or I'm going to call it ground. It could be surface, and normal and friction. So we get 4 forces to draw on A. So I'll do A first, and then I'll do the nuts. Okay, for A is we got Earth, so that's force of gravity, gravitational force. We got tension force in this direction, pulling it. That's Ft, and it comes from K to A. What else do we have? We got the surface here, pulling it upwards, perpendicular. That's F normal from ground to A. And what else? Friction. So if this is being pulled here, it's going to try to go this way, but the surface is going to resist that movement and move it to the left. So it's going to be a force in this direction. That's going to be the force of friction from ground to A. Fantastic. Now, finally, the nut here is going to be interacting with 3 things, A, B, and the wall. So how do we draw that? And also the earth. So sometimes we don't draw force of gravity, and the reason for that is because the nut has such a small mass itself that it doesn't get affected much, but I'm going to draw it anyways. I'm going to call that FG. Block B here is interacting with this via this rope, so it's pulling it down. So there's going to be another force acting in this direction. I'm going to call that force of tension from B to K. A is going to be pulling it in this direction, so there's going to be a force in this direction, another tension force, and that's from A to K. And finally, the wall is going to also pull it through the force of tension. And force of tension from the wall to K. And these are the 4 interactions it has. You can see that it's only connected via the strings here. And those are all tension forces, and it also always interacts with Earth. So I'm going to pause here and call it a day for force diagrams. We did a few examples. Make sure you do some practice questions just to get better at these. But the main idea is to first figure out what are the interactions. So let's take one of the more complex examples. Let's do our system as AB here. So we get our system AB. And first thing we're going to look at is what interactions does it have? Well, we look at, first of all, there's always an interaction with Earth or whatever planet it is on, because that planet is going to be so massive, and that planet is going to pull the system towards it. So in this case, this system is being pulled towards Earth. And that force is shown right here as force of gravity. Then after that invisible force, there's no electrostatic or electromagnetic force because there's no information given to us in terms of electrons, protons, or any north or south side of the magnet. And then we're going to look at the boundary of our system. Within our boundary, I'm going to start from the bottom here. This part is touching the surface over here. And this is the ground. So ground here is going to push this part of our system upwards, and that's going to be through the normal force. Normal force is always perpendicular or 90 degrees to our system. That force is shown right here. That's a normal force from our surface N to AB. Then if our system could also be pushed towards the left, and if that's the case, the friction from the surface will pull it back in this direction. And that's the force of friction from our surface M to our AB, our system AB. So we've taken care of this. We're going to move up. No interactions here at all. No interactions here. No interactions here. Right here, we see force C, and force C is pushing our system downwards. So a force from C to AB is pushing our system downwards. So we see that right here. And we follow it along, nothing else here. And then down here, it's also touching our surface. So this surface M is going to be pushing it normally in this direction. So that's a normal force from M to AB. And also, if there's this force and this force of gravity also acting on it, there's a good chance that this part wants to move down, but the surface or force of friction from the surface is going to resist that motion, and therefore it's going to pull it upwards. And that's what we're seeing here. That's the force of friction from surface M on our system AB. So one last time, for force diagrams or free body diagrams, we look at external forces, we look at how they interact with our system and in which direction they will force them. I hope the video was helpful and have a great day.